What we're going to do now is learn about standard atomic notation. So if you remember back to the periodic table, the boxes in the periodic table tell you all the information that you need to know to find out the number of protons, electrons, and neutrons in an atom. So let's do a little reminder of the information that's on that periodic table. We've got the atomic number. We've got the symbol of the element. We've got the element name. And we've got the average atomic mass. So that's all the information we need to figure out how many electrons, protons, and neutrons in our atom. We've got our atomic number up here, and we've got our average atomic mass, which we're going to round to the nearest whole number. And we can figure out how many protons, how many electrons, and how many neutrons. Now, scientists decided to make a way that is a little bit simpler than looking at the periodic table, the boxes on the periodic table all the time. So this is called the standard atomic notation, and it has just enough information that we need to figure out how many protons, electrons, and neutrons in the atom. So if you notice here, this on top is going to be our atomic mass, and it's rounded, so it's at the nearest whole number. Then we've got the symbol, and on the bottom we've got the atomic number. So it's going to be a little bit different setup than on the periodic table. If you notice here, the atomic mass is at the bottom on the periodic table, but it's at the top in standard atomic notation. And you may also notice that the atomic number is up at the top on the periodic table, and in standard atomic notation it's down here at the bottom. But it still gives us all the information that we need to know. All right, so let's use standard atomic notation and figure out our protons, electrons, and neutrons for an example here. Okay, so our first one here is our carbon. Our atomic number down at the bottom is 6. All right, so it's 6 down here at the bottom. Remember, on the periodic table it's up at the top, so this is a little bit different. The mass is this number here up at the top. It's 12. Now, remember that our number of protons is equal to the atomic number. So in this particular case, our atomic number is 6, so our number of protons is 6. And in a neutral atom, the number of negative electrons is going to be equal to the number of positive protons. So if we know there's 6 protons, we know there's going to be 6 electrons. So we know we can look at our number of protons, which is 6, or we can look at our atomic number, which is 6, to find out our number of electrons. That's in a neutral atom. Now our number of neutrons is going to be our atomic mass minus our atomic number. And it's nice how this is kind of set up as a little subtraction. So we're going to take our atomic mass, we're going to minus our atomic number, and that's going to give us 6. So it's going to be 12 minus 6 is going to give us our number of neutrons. So let's try this now with nitrogen. Our atomic number down here at the bottom is 7. Our mass up here at the top is 15. So that's been rounded up to 15. So again, our number of protons is equal to the atomic number, which is 7. We know if we have 7 positive protons, we need to have the same number of negative electrons so that our atom is neutral. So our number of electrons is equal to our number of protons, which is the same as the atomic number. So we've got 7. And then to find our number of neutrons, we're going to take our atomic mass minus our atomic number, and that's going to give us our number of neutrons. So we're going to do 15 minus 7, and that's going to give us 8. Pretty simple. So there's a worksheet that you can do and hand in. Bye for now.